So let's get the meeting started with the sky this month and Andy Beaton.
Hello. Am I on? I guess I am. Hi, my name's Andy Beaton. I am speaking to you from downtown Toronto in my basement fortress of solitude, and I'm talking about the sky this month. Start off, usual list of what we've got coming up. The big picture, important dates coming up, the moon, the planets, something in the deep sky, double stars, variable stars, and whatever's coming up in the way of interesting spaceflight odds and ends. The big picture we'll start with, we're looking west around sunset later tonight. Actually looking more south on this one because west was looking kind of uninteresting. What we're looking at here is the summer Milky Way and everybody's favorite summer constellations up and down the Milky Way, starting Scorpius at the bottom and heading up to Cygnus at the top. The important thing that we want to look at here is planets. Pluto is there, and we're at the time of year where we've got our favorite gas giants coming up, Saturn and Jupiter there. I also see here that we've got a couple of minor planets, Haumea and Makemake. As it turns out, very few of us are going to see it, but if you're an experienced observer with a large telescope, trying to image one of those would be an interesting project. Heading towards our next meeting on September 8th, we get up at 5 in the morning and take a look out the window. This is what we're going to see. We're going to see all your favorite winter constellations showing up. It's that time of year. We'll have our Taurus and Orion there. And we'll also get the ice giants, Neptune and Uranus, and minor planets, Eris and Ceres. Ceres is one you'll actually be able to see. I know it's depressing to think we're already seeing winter constellations, but you know, the summer is blasting through here. We're past the solstice, so nights are getting longer. Astronomical twilight's going to end around 10:30 tonight and start again at 3:45 in the morning. By the time we get to the next meeting, twilight will end just past 9 o'clock and start again at 4:45. So that's good news for people who need to get up in the morning and can't stay up too late observing. And it's also good news for the imagers who want lots of good time out there to observe and gather up some long duration photos. So important dates coming up, new moon on August 8th. The moon is at apogee on August 30th and perigee on August 17th. I like to include that because I think it's a cool photo project for people getting started in photography to take pictures of the moon at those two times and compare the images side by side and be able to see them, see how much it changes. I've thrown in the notes far and close for apogee and perigee because I'll be honest, I always forget which one's which. August 22nd is the full moon. We have a triple transit of Jupiter on August 15th. Unfortunately, we aren't going to be able to see it here because it's in the middle of the day, but since we're now a multinational podcast here, I've thrown it in anyway. Anybody watching this from East Asia or traveling that way should be able to see it. And of course, the big news for this time of year is the Perseid meteor shower. That's coming up on August 12th and a few days either side of it. And Venus will be occulted by the moon if anybody is watching this from New Zealand. Hello, New Zealand, on May 12th. Oh, what the hell? August 12th. There's always something I miss typing when I go through this. So we get the new moon on August 8th, first quarter on the 15th, full moon on the 22nd, last quarter on the 30th, and this is an exceptional month for us because we get a second new moon before we get to our next meeting. August 15th, we also have the appearance of the Lunar X. And for people who don't know, it's a feature on the moon that when it's illuminated from a certain angle, the intersection of the rims of two craters makes a cool looking X. I mean, it's not scientifically exciting, but it's a cool thing to look at. And if you've got family or friends who are curious about what we do in astronomy, looking for the Lunar X is a cool thing. Unfortunately, it's kind of 6:30 in the morning, so you're not going to have it for your evening barbecue, but if you're getting up early for work, it should be visible. So the planets coming up, the small planets, it's a lousy time for Mercury, at least for the northern hemisphere observers. Farther south, it'll get further from the horizon than it does for us. But up here, it's going to be a dead loss. Venus is currently low in the evening sky. By the time the sun sets, it's pretty much gone as well. It'll be a bit better by the end of the month, but for now, it's there. I really bring it up because one of my cousins called me yesterday saying, "Hey, what's that bright thing in the west?" And I was able to answer her. So I'm sure the rest of us will probably have our friends and family asking the same question. Mars is disappearing into the evening twilight. It's getting smaller and further away as it gets to the opposite side of the sun. It's a mere 3.5 arc seconds across. Even if the conditions were good, it would be really hard to see anything worth looking at. These are the stars this time of year. Saturn rises not long after sunset, and Jupiter follows closely behind. Unfortunately, neither of them are at particularly high declination, so we're not going to get astonishing views of amazing detail. The atmosphere's getting in the way, but moons and rings are still going to be there. And once again, if you've got friends and family who haven't seen these things, drag them out, find a telescope and show them the rings of Saturn and the moons of Jupiter. That's the stuff that makes new generations of astronomers. This is something that Dennis Gray drew my attention to a couple of months ago. The Earth is actually crossing the orbital plane of Jupiter's satellites. It happens every 6 years. We've got 192 observable events from March 3rd to November 16th. We're actually getting close to most of the end of most of them. There'll be a few stragglers into November, but this is probably the last month we'll see more than one. Here's the website if you want to track them down for yourself, but for our own purposes, from Toronto should be 4 observable events. On August 8th, Ganymede is eclipsing Europa. On August 9th, Ganymede occults Europa. And that's the planet or the moon actually passing in front of the moon and not just casting a shadow on it. On August 12th, Io eclipses Ganymede. And August 19th, Io eclipses Ganymede again. So if you're out and observing, see if you can catch these. These are going to be pretty fascinating things. And August 15th, we have a triple transit. Callisto, Europa, and Ganymede all passing across the face of Jupiter. Unfortunately, it's daylight for us here. You might be able to see something depending on how the seeing is. I've looked at Jupiter in the daytime and I've definitely seen the big stripes. I don't think I've ever seen a moon of Jupiter in daytime, but I'm not sure I've ever really tried that hard. So if you're out and about with your telescope at 11:30 on the 15th, give it a shot. What's the worst that can happen? Record a failure. We've all done that. Further out in the solar system, we have the ice giants, Uranus and Neptune. Uranus rises just before midnight, and Neptune rises just after sunset, both of them visible all night. Again, the same problem we have with the gas giants. Neither of them are very high in the sky. Otherwise, they're good. And if you're looking for a challenge project, finding the moons of Uranus and Neptune they take some work. I've seen one. I've seen Triton, and that was hard work. It took a lot of checking and watching over time to see the thing is actually moving, but it was a satisfying result when I confirmed it. And I know they're dwarf planets, but I'm including Pluto and Ceres anyway. Pluto's in Sagittarius. It's getting away from the Milky Way finally, so it should be findable in any 10-inch or larger telescope. I saw it with an 8-inch telescope once, but it was well away from the Milky Way, and there were very few stars competing with it to be confused with it. So I would say, as close as it is to the Milky Way, you'd want something a bit larger than that. Ceres is an 8th magnitude object in Taurus. It's visible in the east before dawn, and it would be an interesting project as well to track it as it moves throughout the month. So I always like to include a bit of deep sky stuff just because there's so much stuff out there. Everything deserves to have a look at it once in a while. The North American Nebula is the one on my mind this month, and there's a picture. We've all seen it before, but this is a really nice one that I got from ESA, NASA, and the Hubble Space Telescope. Monstrously huge diffuse nebula in Cygnus, so huge that narrow band telescope is not going to get it. You want a wide field telescope or binoculars to really get the full thing in. It can be seen with the naked eye if the sky is really dark. If you know what you're looking for, it looks like a brightish patch in the Milky Way. I'm not sure I would be able to distinguish it from any other bright patch in the Milky Way, just a bunch of stars, if I didn't know exactly where I was looking and what I was looking for, but it can be done and it is there. And while you're at it, you can scoop up the dark nebula LDN 935, the Gulf of Mexico, onto your observing log. There we go again. There's that Gulf of Mexico between Mexico and Florida in the pseudo map. As you can tell, it is not missing matter there. It's just dark matter blocking whatever's behind it. There should be way more stars there, but the ones we see are the ones between us and it. And if you're looking at it and you're more than a beginning amateur looking for something more challenging, 13.2 magnitude star, and I won't bother reading out the designation, is the ionizing star for the entire nebula. For a while, they were thinking that Deneb was the ionizing star, but it's not really bright enough to get the whole thing. And if you're interested in other projects, there's a whole bunch of dark nebula in and around the North American Nebula, and mapping them out and identifying them would be a project to take more than a few nights. So we have comets and meteors. The Perseids are the obvious meteor shower. Everybody is always excited about that one. My coworkers are already asking me what's going on, what should I do? And the obvious answer is get as far as you can from the city and lie down and look up. Really starts on the 10th and goes to the 14th, but it is peaking on the 12th. And this year, the moon is setting early, so it should be an excellent meteor hunting year, assuming that A, the weather is cooperative, and B, the forest fires are cooperative. But I plan to be out on a beach somewhere for as much of the night as I can stand looking for meteors. That's the meteor shower. We also have some meteor dribbles. The southern Delta Aquarids, the Alpha Capricornids, the Kappa Cygnids, and the Aurigids. All of them pretty long duration showers, but looking at between 1 and 5 meteors per hour. I wouldn't advise actually going out to look for them just for the sake of seeing them. But if you are out and you do see a meteor, check the direction it came from, check the date, and see if you can identify it as one of those meteors. We have some comets. C2020 P2 Palomar in Virgo is the most promising one. It's just under 10th magnitude. It will set fairly early. Virgo doesn't stay up long. 15P Finley, 10.8 magnitude in Taurus if you're up in the morning. And C2019 L3 Atlas, 12th magnitude in Auriga. 12th magnitude isn't spectacular, but if you're really addicted to comet hunting, it's out there for you. I'm also going to bring your attention to C2021 A1 Leonard, 15th magnitude in Ursa Major, but it's getting a lot of press as a giant comet that's going to be the comet of the decade. Yeah, we've heard that one before. But keep an eye on it. If you've got a large telescope or long-term photography facilities, sure, start looking for it now. See if we can see anything happen before it either becomes big and famous or fizzles like many other comets of the decade have done. I don't know if Blake is here tonight, but I want to keep on his good side by bringing in a double star. Kruger 60 is the one I've found for this month. It's a 9.7 magnitude pair in Cepheus, 9.9 and 11.4 magnitude respectively, and they're about 2 arc seconds apart. So if you can split the stars in Epsilon Lyrae with your telescope, you can split these guys. Now, the reason I picked on these guys is their 45-year period. Depending on the angle of inclination, that means we're going to be seeing up to 8 degrees of the orbit per year. So every year you go back and observe this guy, you're going to see the secondary star moving around the primary. And 45 degrees, that's many of us are going to be able to sit through an entire orbit. Knock on wood, assuming we all live that long. But it's a project that should be manageable. And it's not my sky this month without a variable star, because people who have known me in the Toronto Centre know me as one of the variable star guys. I picked on Beta Persei this month, better known as Algol. This one's different from the ones I usually go for. It's not an intrinsically variable star. It's not a star that varies in itself. It is an example of an eclipsing variable, 2 stars which orbit each other and just happen to be lined up, the plane of their orbit lines up with us. So as the 2 stars orbit each other, they take turns blocking each other's light from getting to us. And that that brightness curve will change over time as one star or the other blocks the other. Now, what's interesting about this is, although it's a nice steady orbit, we've discovered over 100 years of observing that the period is changing very slowly and very, very subtly. And why that is happening is a very interesting question to professional astronomers. So what we can do, that is you and I, is get out there with our telescopes and our observer's handbook. There's a page in here. Your basically your monthly your sky guide will tell you when the minima are expected. Set up your telescope beforehand, and every 10 minutes, measure the brightness, record it. The brightness you're measuring is going to be compared to nearby stars, or you can do it the really cool way and set up a photometer or a camera or something. Measure the brightness of that star, go back another 10 minutes, measure the brightness until it returns to normal. And you can submit that data to the American Association of Variable Star Observers. And what they will do is they will collate that information. And if you are a professional astronomer who wants to know how the orbit is changing for this variable star, you can download that 100 years of data and get that collected wisdom of the thousands of amateur astronomers who have been gathering that data. So we got a few things happening in spaceflight. I'll be honest, we're at the point where Falcon rockets taking up Starlink satellites is no longer a highlight. It's just turned into routine stuff, so we'll skip that. We have Perseverance and Ingenuity on Mars. That stuff never gets old. I'm old and jaded in the astronomy business, but seeing a helicopter fly on Mars is just too cool. We have a Boeing Starliner crew capsule test coming up sometime soon, and the flight time is to be determined. I think it was supposed to go up yesterday and got postponed. We have the Chinese rover driving around on Mars. They're the second country to actually get a working rover on Mars, so I'm sure they're going to have interesting things to share with us. Over the next month, the ISS will be passing over early in the morning from 23rd August until the next meeting. I don't think anything visible will be happening in the night until then. If you're not in Toronto or you want exact times and locations, heavensabove.com is the place to go. And because I have been an astronomer for a long time and I know it can happen, I can tell you that you're going to be facing many cloudy nights or many nights when the wood smoke from the forest fires is too much and you'll want something else to do. So I'm going to direct you once again to zooniverse.org, where there is a heap of citizen science projects. We have the Zwicky Chemical Factory, where you are going to be invited to analyze data and search for elements created in stars, whether in supernova or any other nebula resulted from exploded stars. We have Citizen ASASSN. I bet they pronounce it assassin because it sounds cool, where we're classifying variable star curves. Aurora Zoo, which is all about the classifying different types of aurora and timing it with different behavior on the sun. And the old famous, old classic Galaxy Zoo, where you get shown a picture of a galaxy from some deep sky survey, and your job is to identify the type and classify it for the use of, once again, professional astronomers. And I hope we get enough clear skies that all this won't be necessary, but there they are if you want them. And that's what I've got for this month. Thank you very much. And if there are any questions, I'm ready to answer them.
All right, Andy, thank you so much for a great presentation as always. I know it takes a lot of time to prepare it, so thanks again. Let's go to Ennio with questions.
So I have a few questions myself, if I may ask. For SEA 2020 T2 Palomar, is it showing any sort of tail yet? And for SEA 2021 A1 Leonard, what's the expected brightness?
Okay. Palomar, as far as I know, there is no tail visible, at least not from anybody I've talked to with a telescope of an amateur size, 8 to 12 inches. As for Leonard, expected brightness, I have No idea. It's pure wild speculation. It's a large comet, and it's going to be coming fairly close. But the problem is predicting brightness of first-time comets is unnaturally difficult. It could be above 0. It could be 6. Nobody really knows, and I don't think I've ever seen anybody make a prediction they want to stand by. That having been said, I'll make a wild prediction and say it'll be above 0. It'll be the brightest comet any of us have seen in decades. And if I'm wrong, I'll give you your money back.
Thank you. We have a question from Leo to Kath. How long does it take Algol to decline from full brightness to the minima?
Well, that is an excellent question. I don't know off the top of my head, but if you're a member of the RASC, you probably have this fantastic book here. And it will tell you that the period between maxima is 2.8 days, but it doesn't actually tell you how long the minima itself lasts. I believe it's on the order of an hour. It's been a while since I've actually done that one. I've done a couple of other ones which tend to be between 15 minutes and 2 hours of brightness. So I would have to look that up to give you an accurate answer.
Leo to Kath has a follow-up on that question. Off topic, the period, but from the start of the decline to the minima, or rather not the period, but from the start of decline to the minima.
Yeah, that's one I don't have an answer for you quickly or easily. I'd have to look that up.
Okay, and I have one more question. For the Perseids expected this year, how many meteors are they expecting per hour at peak?
Usually the Perseids peak at about 60 an hour. If you're under a dark sky, you'll see 1 a minute on average. The brighter the sky, the fewer you're going to see. If you're looking from Toronto, you might see 1 every 10 minutes.
Cool, and I believe that's all the questions we have. Thank you.
Okay, thank you.
Right, thanks again, Andy, for your presentation.